Hello, learners. Hope you are keeping well. Today is another section on grade 11 geomorphology, and we're going to pay specific attention to the slope elements. All right, the slope elements itself, and we're going to describe them. We'll answer various questions on them in order to get a better understanding. So let's not waste a lot of time. Let's get going with the section itself. So let's look at this. Let me get my ugly face out of the way. All right. Now, what did we notice? Here, there are four slope elements that we have here. All right. Now, they each are found along that slope. So let's go right to the top now. If we look at this area here where the arrow is pointing to, can you see it? It's quite convex in shape. Can you see it? Right. So it's not very big. So it's a small convex shaped slope. It will have thin covering of soil because you must remember the soil gets washed down or gets pulled under the force of gravity. But the main thing here, it's convex in shape and on the top. And of course, we're going to call it a crest. Now, learners, what am I doing here? I'm just doing it in a nutshell, briefly, because I like to link it to the diagram first, and then we do a more detailed discussion on it in our final summary and revision of what I discussed now. Okay? You will also find that there are different names. All right, like the crest may have the waxing slope also. I'll give you more names as we go across. I don't want to give you all the names now and confuse you. Okay, so let's get that clear. Then we come to a next slope. Very, very steep slope. Vertical, almost vertical. All right. Very, very steep slope. That's the second slope down there. All right. And this is known as your scarp, which refers to something very steep, or cliff, which is a steep slope. All right. And you'll find that we'll also maybe call it a Freeface slope later. So there's so many different names, but we'll go through them. All right. So this is a near vertical slope more than 80 degrees to the horizontal. So if you have the horizontal, all right, it's more than 80 degrees. I'm drawing my horizontal here. All right, it's more than 80 degrees down here. All right, more than, so it's almost vertical or vertical. Very, very steep slope. All right, okay, so that is down there, the scarp. All right, a steep slope. Then we have a next slope, which is very nice on a constant angle. Can you see it doesn't go like this and like that? It's got a constant angle. All right. And it forms from eroded material from the crest and the cliff, and they get deposited here. All right. In this. So that is why the name Talus, Scree, or debris. Lots of names for it, eh? All right, all referring to deposited material. All right, debris is the material deposited. Scree can get deposited right at the end of the cliff coming down. All right, so this is the talus, a slope with a constant angle. Can you see there? And is formed from eroded material from the crest. Ah, there's the name Freeface. So the scarp is also known as the Freeface slope. So eroded material gets deposited there. Now, the last slope here is known as the pediment. It's a low angle concave. Can you see the concave shape? And it's quite gentle here, so it's a low angle concave shape. Crest was convex. Now this is low angle concave, known as the pediment. Now, somewhere along the line here, we will have a change in gradient. Okay, that means sun is steep or gentle, and then it changes gradient, maybe gets a bit steeper. So that is known as the Knickpoint. All right. It's the change in gradient at the base of the Scree slope. Can you see the Scree slope here? The end of the talus or the debris or the Scree slope. Right down here, we have a change in gradient. Now, this is very small. I've enlarged it here. Can you see the talus or the Scree slope? And there we have the pediment. And what do you notice down here? All right, the gradient suddenly changes and then it becomes gentle. That's how we have the concave shape of the pediment. Okay, and this change in gradient is known as the Knick point. So in a nutshell, that is your slope elements. All right, now let's go a little further. All right, I just used this Cuesta that was found in the Magaliesberg. And I realized that they have slope elements, that they exist, these sort of things. All right, if I looked here, that's the crest. Can you see it? And if I looked here, that seems to be the cliff. And if I looked here, that is the talus, a constant angle slope. So it's beautiful that these things do exist in reality. And of course, maybe if I went a little further, I would have found a pediment down there. Unfortunately, my picture that I've taken, all right, that downloaded, just had it down there. But there would have been a chance that we have the pediment at the bottom. So it's beautiful how we see these aspects in reality. So let's then summarize. So we learned the crest right on the top. It's also known as the waxing slope. All right. We've already learned it's a convex shaped. It has a thin layer of soil covering it. It experiences soil creep. This is a slow downward movement of particles. So if I had it down here, learners, all right, and I put a fence here, okay, after soil creep happens, it moves slowly down, and suddenly you'll see the poles of the fence have moved, meaning that there's soil that slowly moves down the slope. That's known as soil creep, as if it's slowly creeping down. Okay, you even find roads starting to crack, etc. That happens there over time, and that's what happens along this slope. The geomorphological activity is actually soil creep. Okay, that happens and it moves down. But this is generally the stuff, and there's an additional name. So let's go to this one. Whoa, cliff, scarp, and we know it's a Freeface slope. All right, and examiners can use anything. So we already learned that this is the second slope. There is near vertical slope. It's more than 80 degrees to the horizontal, and it experiences erosion because it's a very steep slope. There'll be no place to deposition to happen here. Eh? So erosion would happen here. And then we said, as we went through our little diagram, the talus, the scree, debris, all these alternate names. We know that this is the next one. It has a constant angle, if you remember. All right. Uh, that's how it looks, but I made it a little funny in the end. It formed from eroded material from the crest and cliff. And of course, it experiences deposition. Material gets deposited there from the crest or cliff. And the last one we looked at was the pediment, also known as the waning. I hope I'm pronouncing that correctly. I always have problems. Waning slope. All right, apologies. All right, this we said is a low angle slope. Remember, from the scree or talus, we get this low angle slope that's happening. All right, it's concave in shape. We analyze that. It's steep near the scree slope and gets flat and gentle as we move away. So what we're saying here is there's this, you looked at it just now, it gets steep there and then we go. And what is this change in gradient here? That's your Knickpoint. Where there's a change in gradient, it gets steep and then it gets gentle. That's what creates the concave slope. All right, it's called the Waning slope because it becomes less steep and grows in size when the other slopes elements recede, means move backwards. So what I'm saying here, learners, let's just draw something for this, all right? Let's make some sense here. We will be coming across this concept later. Let me remove this, all right, and remove this, okay, and this, right? And let me go back and create with my highlight. What do we mean by this? So we have the crest, we have the cliff, we have the Talus, and then we have the pediment. Now, what happens when this recedes? It moves backwards. Okay, so let's create it as it's moved now. There's the crest, there's the cliff, there's the pediment, the talus, and of course, from there to there, it's moved now. All right, and what do you notice? There's your change in gradient. It's gentle. And there's the whole area here. Because this has moved now. Now look at the size of that pediment. Hasn't it grown in size when the other slope elements recede? Can you see that? It moved from there to there. And this whole area now becomes the pediment. It grows in size. It's very interesting. Landscapes change over the millions of years as we move through. Unfortunately, we won't see all of that. We don't live for a million years. We never know the future, but this is how it changes also. So those are the four slope elements. And you also have to remember the word Knickpoint. All right? Knickpoint. My slides almost disappeared. Right. So let's look at it in terms of slope elements. Would we find all these slope elements on every slope? All right. I showed you the slope there in the Magaliesberg. We noticed that there's few slope elements following the pattern from crest to cliff to talus and most probably the pediment. But would we get all of this in all slopes? Unfortunately or fortunately, I don't know, but let's not look at unfortunately or fortunately. We don't get them in all slopes, all right? Let's look at this slope. This slope has hard and soft rock, alternate layers of hard and soft rock. So what's going to happen? With the hard rock, you may find less erosion or weathering. With the soft rock, you will find more. And then if it's alternate layers, so what has happened here? Hard rock, you found a cliff. Soft rock, you found a talus. And immediately after that, there's hard rock again. So you found a cliff. Soft rock, talus. Hard rock, cliff. Soft rock, talus. So what's happening? You don't find them, for instance, crest, cliff, talus, pediment. You will find that if there's alternate layers of hard and soft rock, the cliff and the talus are repeated. All right, you won't just get all the slope elements. So all slope elements may not be found on a slope. Slope elements can be repeated, as in our case here, when we have alternate layers of hard and soft rock. The cliff and talus are repeated. Okay, there's various names, Freeface and whatever, but they're repeated. Do you understand? I'm sure you understand that. We could also have another situation, learners. All right, a gentle slope may not have a cliff, also known as a Freeface, also known as a Scarp slope. All right, if you look at this gentle slope here, can you see it? We can see the talus clearly. We can see the convex shape on the top, but we see no cliff. So in some cases, the cliff may be missing. So we'll get slopes that have all four slope elements, but we must remember that in some cases, there are not all slope elements found on those slopes. All right, doesn't mean the theory now is totally useless. It's given us a lot of insight in terms of slope elements, etc. All right, in terms of this explanation, that you will find these slopes, but not on all slopes. I keep saying unfortunately, eh? All right, let's look at a little exercise now. Refer to figure 1 slope elements. Now, of course, this is figure 1. Let's see what the examiner has given us here. All right. A, we learned there's 4 slope elements. Eh? So A is right on the top is the crest. B is the cliff, and of course, Freeface, Scarp. C is the Talus, Scree, debris, and D is the Pediment or Waning Slope. All right, I hope I'm pronouncing that correct all the time. So we learned that. We can see the steepness of this slope, the convex, the constant angle, all right, and this is a gentle concave slope. So we've picked up all that. Let's look at some of the questions, all right. Identify slope elements A, B, C, and D. The examiner has been nice here. Eh? He's put all, or she's put all in order. So we already learned that. A is the your crest or waxing, but crest you put first. B is a cleft, a scarp, whatever. C is the talus, all right. D is the pediment or waning slope. Okay, let's look at this. Which slope element has a constant angle? Of course, you looked at this and you know the constant angle is C, which is the talus. Write the word talus, all right. C, talus. Let's go on. State the difference in shape between slope element A and D. Watch out here. Some people just read this, say the difference, and they just talk. Watch out. Highlight difference in shape. Very important. And then A and D. And when we go back here, we will notice A has a convex shape. D has a concave shape. And that's your answer for that, eh? A, convex, D, concave. Explain how slope element D grows in size. Now, you've done it when we looked at our presentation here. Okay, and of course, you've learned already that D is your pediment. And as the other slope elements recede or get eroded backwards, all right, as I've explained to you, what happens next? The pediment grows in size. If you remember that on our sketch, all right, I did that here. I said, there we are here. And of course, we got that and there. And of course, when it goes there, I want to repeat this so we get it clear. Okay, we've got that, and then we've got that, and then we've got that. Okay, as the other 3 slope elements, A, B, C, recede or get eroded backwards, the pediment grows in size. Is slope B associated with erosion or deposition? Let's look at slope B. We can see it's the cliff, it's too steep. So it is erosion. Nothing really can get deposited. Okay, so slope B is associated with erosion. All right, give a reason for your answer. It's a very steep slope, almost vertical slope. So you're not going to get much deposition there. You understand? You're going to get erosion. That would be your reason. Then look at this last question. Explain the significance of slope element D. That's how some of us read. Explain. But there's a special word here, agricultural. It'll include everything under agriculture, whether it's farming, forestry, whatever. You understand? So all these things. Now let's look at slope element D. It's quite gentle, eh? So it's gentle to flat. And it's ideal for doing agriculture. Can you see? We can include other things in there that we never discussed. We make you think slightly out of the box, which is not difficult. So that question we have to look at, what's so different about D compared to the others? It's a fairly, it may have a little steep at the beginning from the moving from the talus, but then it's fairly gentle and it gets extended as the other slope elements recede. So agricultural significance is that it has gently to flat land, which is ideal for agriculture. Can you see we can answer any question in this? Learners, I hope this has helped with slope elements and we guided you with some questions. I'm sure your teachers will have even better questions than I do. Okay? All the best. Goodbye.